All right, today we're going to solve quadratic linear systems graphically. First, I'm going to teach you how to use your calculators. And then we're going to solve them, like, basically by any method you want, graphically or algebraically. All right, so here you go. This is what they wrote down. Notice things are flipped around. Does that bug anybody out? Okay. I want you to understand that the first step towards solving these equations graphically is to always get it in, like, y equals form. Some people say, but what about the top? It's not y equals. Can I flip it around? What do you think? Yeah, of course you can. This is really the same thing as y equals x plus 2, right? Yeah. Okay. So here's what we're going to do. Here's what we're going to do. Grab your calculators. Grab your calculators. And we are going to, does everybody's calculators work? Just hit the clear button. Now here's what we're going to do. Everybody knows that, like, well, actually not everybody knows this, but when we are talking about graphing and you use your calculator for graphing, all the buttons that you really want are up on top. You don't need to search around down in the bottom. So hit the y equals screen, enter it in. You see these are y1, y2, y3, y4. We're going to enter in x plus 2. X plus 2. Does everybody know where the x button is? It's next to that alpha key. And then we're going to scroll down one. And we want to enter in negative x squared. Negative is this button at the bottom. You can't use the subtraction symbol. They're different. X squared minus 3x plus 7. Now, the tricky part about this is going to be adjusting our window and finding the points of intersection. Has everybody in here done this once before, maybe? Kinda? Never done it before? Ever? Hit the graph button. There's our line. There's our parabola. Okay, here we go. So now, what do we do next? Does anybody know? Yeah, we're going to hit second trace because we want this calculate section. When you hit this yellow button, it means you really want everything that's written in yellow. So second trace, and this is going to be an enormously popular screen for you. Okay, it does lots of stuff. Value, 0, minimum, maximum. We want intersection. Okay, and then you can see you can, like, move around. If you move left and right, you move on that one. If you move up and down, you can jump curves. So what you want to do is you want to try and get nearest to the first point of intersection. So get over here and then hit enter 3 times. 1, 2, 3. So our first point of intersection is -5, -3. So that's one of the answers. -5, -3. Now, one thing that you could do is on a test, if you solve a problem algebraically and you don't feel like checking through all your work, what can you do to just check it real fast? Just plug it into your calculator. Check it like this. You know. Okay, that's one of the answers. Now let's go get the other one. Here's my calculator, right? You have to go second, calc again, intersect. And then what you do is you want to move down near the other one. Move down over here, hit enter 1, 2, 3. 1, 3. 1, 3. And that's it. And then we'll put our solution set brackets around them, and that's how we do it. So take a look. Can we plug this into our calculator? No, of course not, because they both have to be y equals. So we're going to take this one on the bottom, we're going to reorganize it, we're going to subtract x from both sides. If you subtract x from both sides, you get y equals -x plus 6. Yeah? Let's just review just for a second, just so people are on the same page. This is the equation of a line or a parabola. What's the slope of that line? Nah, -1. What's the y-intercept? 6, right? This up over here is called a what? Parabola. What's a synonym for a parabola? Starts with a Q. They mean the same thing. Don't get freaked out by that stuff. Okay, all right.
That one on top is the quadratic because of the square.
Yeah. Yeah. That one on top is a quadratic because of the squared. There's actually really only three types of shapes. We're gonna take a small slight detour just for a second, just so you know this, right? Let's eliminate this, eliminate this. We're gonna get back to our problem in a minute. Y equals x. What kind of shape is that? It's a line. It's a line. Y equals x. If you don't see a power up there, right? It's just a line. Then watch what happens when you start to put powers up there, right? Y equals x. What happens when you put x squared? What kind of shape is it? We just talked about it. Parabola. What's a synonym for a parabola? What else could I call it? A quadratic. Take a look at the shape of it, right? It's U-shaped. Then watch what happens if I do to the third power. What does it look like? Does anybody know? This is called cubic. In cubic, odd powers always look like S's. Okay? Watch. And then you'd think, oh my God, math must get crazy, right? It must get outrageous. Watch what happens when I put a fourth power. What do you think it looks like? Yeah, it goes back to being a parabola. The only thing that changes is that as you increase the powers, it starts to get all wobbly in between. It almost looks like a radio frequency, but then it comes back up. And then watch what happens. What do you think the fifth power looks like? Looks like an S. And so we talk about, when you get to pre-calc, odd powers and even powers and what they look like and end behaviors and things like that. All right. But right now we've got an even power, so it's U-shaped. What's up? The negative power? Negative is really, you know in geometry when you learn about like transformations? Yeah? Watch. And we kind of talk about this in functions a little bit. When you like negatize something, right? Negative x squared, you know what you're really doing? You're reflecting it. X. Oh, exponential functions. Oh, I mean, x raised to the negative second looks like that. Okay. You should genuinely try and. Hold on a second. That's not really what it should look like. Second, insert, parenthesis, close it up. We should have done this. Oh, yeah. No, because it hasn't, that's right. Anyways, back to this. Let's go back to our original problem. Let's plug it in. 3x squared minus 2x plus 4. We're going to go to the other one. We got negative x plus 6. We're going to graph it. There's our graph, right? What do we do next? Second, trace. We're going to go down to intersect. We're going to go over to the first one. It's kind of hard to see. Enter 3 times. Oops. Okay. Now that's going to be a problem. Does anybody know what 0.6 repeating is? It's a good thing we haven't been using calculators for it. What is it? Close. It's 2/3. So x is negative 2/3. Okay. I'll show you something else. Y is going to be 6 2/3. Now, the only other way that you possibly could have written it is like what? Yeah, negative 0.6 with the bar on top and 6.6 with the bar on top. You could have written it that way also as well. You'd get full credit. But if you don't put the bar on it, you're wrong. It would suck to get that wrong. Okay. Let's go to the other one. What's up? Yeah, man. Right? It's repeating. The only reason there's a 7 at the end is because your calculator rounded. Yeah? All good in the hood? All good in the hood. All right, let's do the other one. Second calc, we're going to go to intersect. We're going to scroll around. We're going to go 1, 2, 3. It's 1 comma 5. The other one is 1 comma 5. And then finally, we're going to put our big solution brackets over it. No, you don't. I just put that in there just to say, like, you could have written one or the other. Like in geometry, remember that? When are or statements true? When, yeah. Okay, all right. So anyways, so now solve by any means necessary. That means, what can you do? You could solve it graphically. You could solve it algebraically. Which way do you prefer? Oh, you like graphically? Why? Oh. Okay, all right. Well, maybe we'll do both. Let's see what happens. First of all, they're all lined up. Let's use our calculator. Let's see if we can figure out the answer. Right? 2x squared minus 5x minus 3. And then we're going to do 3x minus 3. That's kind of questionable. It's hard to see if it hits. You see how it hits at the very, very top? Okay. Some people might get freaked out about that. How do you move the screen around? Window, right? And now, what do all these things mean? What does min and max mean? Minimum means left. Maximum means right for the x values. Minimum for the y values means what? Down. Maximum means up. You understand? Okay. So now let's go back to that. What do we need more of? We need more up. And so which one of the things on this screen is that? Y max. We need more up. They really should relabel that, to be honest with you. It always confuses people. So, I don't know. I just put it to whatever I was feeling at the moment. I'm serious though. That's kind of how it works. I think that's what freaks people out about the window. It's like, how did you know to choose that? I didn't. I just kind of guessed at it. Yeah? What do you mean? Yours might look different. Okay, let's go. Time to go. Second calc. Let's go to intersect, right? We're going to scroll over. Oh, lucky for us. It's already on that spot. What is that? That's 0, negative 3. That's one of the answers. 0, comma, negative 3. And then let's go back to the other one. Second calc. Enter, enter, enter. Hit enter 3 times. It's 4, comma 9. 4, comma 9. That's all we do. That's, I forgot about that. I was going to make sound effects. You know that song by Montel Jordan? This is how we do it. I was gonna do it and have it on there so when we finished it. I was gonna push it and then he would just sing. Okay, so now we're gonna start just a little bit of new stuff. This can easily be taught in 5 minutes. It is super, super easy. All we're gonna talk about is domain and range. Domain. We're right now going into functions. We'll talk about what functions are, but domain and range. Domain, anytime I say that word, it means the x values. Okay? You'll also hear it referred to as like the set of inputs. Inputs, x values, domain, all the same. There's also the range. The range. The range, when I say it, I mean the y values. And a really fancy way we could also say it is the outputs. So outputs, y values, range, all the same. You got it? Start this. Okay. We're gonna start it today. We're gonna continue on tomorrow. So what they're gonna ask is they're gonna give you some coordinates, some inputs, right? And we're gonna ask you what are the domain and what are the range. Okay? So the domain, the domain and the range of this. Okay? So you don't have to necessarily take this down. We're going to go over it tomorrow. Let's just pay attention to it. Just out of curiosity, what's the domain of this set of items? What are those? Does anybody know what those are? What is Albany? What is Bismarck? What is Juneau? Specifically, what are they? Thank you. Yeah. Bismarck, Juneau, and what is the range of this set of items?